Hello, this is going to be Calculus 1 final exam integration section. So let's start with the integration section. So this is a practice final exam, and let's start with question one. So question one, we have like a table. We have an x coordinate of 2, 4, 6, 8, and a y coordinate of 10, 30, 40, and 20. It says, using three subintervals of equal lengths, what is the left? What is the left and approximation from 2 to 8 of f of x d of x. So we're doing Riemann sum because we are doing left side. So first what we got to do is find delta x, right? So step one. Um, my delta x is going to be b minus a all over n. And my b value is the largest x. So that would be 8. And my a value is the smallest x or the first x, which would be 2. And then my n is how many x values they have. So we have a total of 1, 2, 3, 4. We do have, oh, n represents the three sub intervals. So you're going to replace that with 3. Okay, so we need to find delta x to do this. Yes, so what's 8 minus 2? 6 divided by 3, and then 6 divided by 3 is 2. So my delta x is going to be 2. We're going to need that. Okay. Step two, you can kind of draw like a little image. So if you kind of draw an image, it would look like this. There's 2, there's 4, there's 6, there's 8. Okay, so if we're doing the left side, how would that work? So now what I would do is step 3. Um, so we're going to do the left-hand side. If you zoom out, I want to see, because I can't even see the table anymore. So let me try to zoom out. How do I zoom? Here we are. Let's see if this is better. Okay, I zoomed out. So now we're gonna do is step 3. We're gonna do the left hand side, which is basically delta x, and it's gonna be f of x naught plus f x1 plus f of x to the n minus 1. So let's fill in our blanks. Our delta x is 2. What is my f of x naught? So our x naught is 2, so it's gonna be f of 2. And this is where you're going to need the table, plus f of x1. X1 is 4. And then f of, I believe, 6, right? So we're going left-hand side. So that's why we don't include this 8. So so it's just 2 times what's f of 2. So if you look at your table, f of 2 spits out 10 plus what's f of 4? F of 4 spits out 30 on your table. And then f of 6 spits out y value 40. So when you put it all together, it's 2 times 10 plus 30 plus 40, which is 80. So 2 times 80 is 160. Okay, so this is the left-hand side method of the right-hand side. And we get an answer of 160. Okay, let's do question 2. So question 2 is just like 1. They give the table if 4 equal subintervals, so they're using 4. I think that's going to be our n. Are used, which is the trapezoid approximation from 0 to 2 of f of x d of x. So we're going from 0 to 2. So from here to here. So I always start with this one. Well, what is the area of a we're doing trapezoid. So what does a trapezoid look like? It kind of looks like this. Right? This are your big legs, base 1, base 2, and then this is your height. And what is the area of a trapezoid? So the area of a trapezoid is 1/2 times h plus the addition of all the legs, b1 plus b2, right? So in our case, it would be 1/2 the h. The h is like our delta x, and then it's going to be f of x1 x1 plus f of x2, etc. So we're going up to 2. So, um, did it say left side? So let's do this one. So how do we do the trapezoidal method? If you need to copy the table, go ahead and copy it down. Here's our table. So it is going to be so this is going to be a equals 1/2 delta x bracket, and then we're doing f of x naught plus 2 times f of x1 plus f of x2 plus f of x n minus 1 plus f of x n. Okay, so what we're do first is step 1. We're going to find our delta x, right? So step 1, find delta x. So delta x is b minus a over n. And my base, my b is we go up to 2, so our b is going to be 2. And our starting value, so we're going from 0 to 2, right? That was part of the problem. 0 to 2, that means 2 is your b, and then 0 is your a, right? So it's 2 minus 0, and then what is our n? My n, they specifically said to use 4 equal subintervals, so I believe our n is going to be 4. Okay, so 2 minus 0 is 2, 4, and then that reduces to 1. Okay. So we found our delta x. Now let's do step 2. Step 2 would be, I guess, kind of draw an image. So it's going to look like this. start from 0, and then 0.5. Okay, so we kind of like draw a trapezoid, so this is this. Doing the best I can. Okay, so that is our image. So now what we got to do is use the formula. So step 3, it's going to be 1/2 because that's the area. So yeah, 1/2 times delta x, which is we just found out, which is 1/2. And then it's going to be we're doing the trapezoidal method, so it's going to be f of 0 plus 2 times f of 0 plus f of 1 plus f of 1.5 plus f of 2, close it in the bracket. So see, 1/2 times 1/2 is easy, it's 4. And then you're going to go back to your table and figure out what are the y values for these specific x values. So what is the y value when 0, when the x value is 0, that is given as 3. What is the y value when f of 0.5 is? That is, it's 3. Okay, so this is all in parentheses. So, okay, so y value when the x value is 0.5, it's going to be 3. What is the y value when the x value is 1? It's 8. What is the y value when the x value is 1.5? 8. And then I guess, oh, this f of, sorry, this f of 2 is not, it's in this, so it's f of 0 plus 2 times bracket of this whole thing, and then this is not part of it. So you got to figure out what f of 2 individually is. F of 2 is 13. Then close it with the bracket, right? Okay, good. Now, just you got to plug this in your calculator. So this is 3 plus 2, and then 3 plus 5 plus 8 is 16, plus 13, close in the bracket, and you get 1/4, 48, just 12. Okay, so that's the answer. And so this is called the trapezoidal approximation from 0 to 2. Okay, so let's move on to. So 3 here we also have, we're given a table and they're asking you what is the trapezoidal approximation from 2 to 8. So I think 2 is your A and B is your 8, right? Um, so it's just like the other one. What I would do is from 2 to 8. So it's kind of like draw an image. It's 2. It's gonna be 7. So it's going to be 1/2. And it's gonna be it's gonna be b minus a over n, right? Uh, but what is my delta x or my h? Oh, I think it's gonna be so my delta x is gonna be b minus a, so it's gonna be 8 minus 2. And then how many intervals do we have? One, two, three, four. Equals 2 is equals 6. Oh, and we have 3 subintervals. So one, two, three. So it's going to be 1/2 times 3. And then it's going to be f of 2 plus f of 5. So 1/2 times 2 times f of 5 plus f of 7. Close over the bracket. And then it's going to be, is that it? Hold on, did I do this? 1/2 times 3, 2, so 1/2, 7, 2. Oh yeah, this is right. Okay, I was just double checking. So yeah, so it's going to be 1/2 times it by 3 because we started out with 3 subintervals, and then f of 2 plus f of 5, and then over here it's going to be 1/2. Now we're dealing with 2 subintervals, so I put a 2 here, and then it's going to be 5 to 7, and then that's it. So you just fill in the blanks. So it's going to be 1/2 times 3, and then f of 2. F of 2 plus f of 5, f of 2 is 20, 5 is 30, plus times 2. And then f of 5 is, what is that? 5, 30. 7 is 40. So when you put it all together, you should get 175. Okay, let's move on to 4. Oh, I mean, fine. Okay. So this one, we're not doing approximation anymore. We do have boundaries from 1 to 2, and we just got to know your integration rules. So there will no be plus c because we have boundaries. So what is the integral? We'll just take the integral of each term and then go from do the fundamental, right? So what is the integral of 4x cubed? It is 4x and then whole power plus 1 divided by that power, so 3 plus 1 is 4. And then what is the integral of negative 6x to the 1? So it's going to be negative 6x whole power plus 1 divided by that power. So if you kind of move this up, this is going to be 4x, and then 3 plus 1 is 4, 4 minus 6 over 2 is 3, x squared, and then just 4 cancels, you're left with x4 minus 3x squared, and then we go from 1 to 2. You apply the fundamental, right? Okay. So when you do that, you get 2 to the 4th minus 3 2 squared minus bracket, and then do the lower. So that's going to be 1 to the 4th plus 3 to the 1 square bracket. And 2/4 minus 3 squared, I believe that's going to be 4 minus, and then 1 to the 4th minus 3 to the 1 square is minus 2. So 2 negatives becomes positive, so 4 plus 2, which is 6. Okay, so this one's not too bad. You just need to know your integration and apply the fundamental. Okay, let's move on to 6 then. Just like 5, you have boundaries from 1 to 2, and it's the integration from 1 to 2 of 1 over x squared dx. And we have we're going to have to apply the fundamental because we do have boundaries. So what would I do? How do I take the integral of 1 over x squared? Would I use substitution? No. No, not yet. But how can maybe I could rewrite 1 over x squared as a negative power. So how can I rewrite 1 over x squared as a negative power? That is the same thing as x to the negative 2, right? And then just take your integration rule. So what's the integral of x to the negative 2? So it's basically whole power plus 1 divided by that power. So negative 2 plus 1 is negative 1. So that's going to be x. And then negative 2 plus 1 is negative 1 over negative 1. X to the negative 1 is 1 over x, right? X to the negative 1 is 1 over x minus. So the integral of x to the negative 2 is negative 1 over x. And then because we have the boundaries, we've got to apply our fundamentals. So lower boundary is 1, boundaries 2. So it's going to be negative 1 over 2 minus bracket. And it's going to be minus over 1. So it's going to be negative 1/2. 2 negatives becomes a 1. That negative 1/2 plus 1 is 1/2. Okay. Let's move on to question 7. This time, okay, so our boundary is from 0 to x, which is not a number, and then the integral sine of t of dt. So even though, don't freak out if this is not a number, if the upper boundary is not a number. Well, let's just leave it as it is. Let's just leave it as an x. So what is the integral of sin of t? Yes, it's negative cosine of t, right? Then you just apply your fundamentals. My lower is 0 and my upper is x. So apply the upper minus the lower, so it's negative cosine of x minus bracket minus cosine of 0. Okay, so this would be negative cosine of x. Two negatives become a positive, so it's going to be cosine and then 0. And it's going to be something like cosine of x. And then cosine of 0 is positive. There you go. There's your final answer. Okay, let's move on to question 8. So we have the integral from 1 to e of x squared minus 1 over x all over x of d of x. So how should I do this? Um, Should I use U substitution? I don't think it'll work if we do use U sub. If you use U as x squared minus 1, wait. Yes, you can. You can. I think U substitution will work. If you use U equals x squared minus 1, and then if you did your du, this would be 2x dx. Oh, no, it wouldn't, because you want some kind of 1 over x. So U would not work. So what should you do? Well, this is all over x, so maybe we can rewrite this as 1 over e, 1 to e, and then just divide each term by x, right? So maybe x over x minus 1 over x of dx. Okay, so point set, so 1 over e. What is x squared over x1? That's x1. And then you have negative 1 over x dx. Okay, so now we can just take the integral of each term. What's the integral of x? What's the integral of negative 1 over x? That's easy, right? So the integral of x is just use your integration rule. So it would be at whole power plus 1, so 1 plus 1, 2, minus, what's the integral of 1 over x? That's a special one, and no, you don't have to use U substitution. It's going to be ln of x. Okay, so this is going to be x squared over 2 minus ln x. And then you may do the fundamental theorem. So my lower is 1, and my upper is e. So it's upper minus lower, so it's going to be e squared over 2 minus minus bracket, and then do the lower, so it's going to be 1 squared over 2 minus. So e squared over 2 is e squared over 2, and then ln and e cancels, it just becomes 1. So it's minus 1 minus, and then 1 squared over 2 is 1. And then ln of 1, if you put that in the calculator, that would show be 0. So this cleans up as square 2 minus 1 minus 1/2 minus 0 is 1/2, right? So this up a bit. Uh, oops. So when you clean this up, it's going to be square root of 2. And then negative 1 minus 1 is negative 3/2. And that is your final answer. So let's move on to 9. So 9, we have the integral of 1/2 e to the t over 2. Oops, it keeps on going down. Okay. So then we have the integral for number 9, we have the integral of 1/2. From the integral of e raised to the t over e raised to the t over 2 of dt. So notice that the constant is outside, so that's good. What is the integral raised to the t over 2? T over 2 to 1. E raised to the t over 2, or you could think of it as e to the 1/2 t. So the integral of that is basically itself, e to the 1/2 t, or t over 2, divided by the derivative of the power. So what is the derivative of 1/2 t or t over 2? Yes, it is 1/2, right? So divide this up. Clean this up, you should get, and you should, the 1/2 cancels. So you're just left with e to 1/2 t, or e to the t over 2. And then because we don't have any boundaries, it's going to be plus c. Okay. Okay. Move on to 10 then. It doesn't stop. Off. Okay, number 10. So here we are, number 10. We have f of x equals from the integral from 0 to x, uh, the integral of t cubed plus 1 of dt, and we got to find f prime of 2. So how would we do this? We would have to use fundamental theorem of calculus number 2. So basically, you're going to use this du over dx from the integral of gx to h of x, and it's going to be f of t dt. Okay, so what happens is, the derivative and the integral cancels, and now you're left with so yeah, this cancels. So now you're left with f prime of x is equal to f of h of x times h prime of x minus f of g of x times g of x. So that means is equals the square root of so when you plug in h of x, it's going to be x cubed plus 1 times h prime of x, which is going to be 1 minus f of g of x. Our g of x, yeah, is 0, so it's going to be the square root of 0 cubed plus 1 times g prime of x. So our g is 0. The derivative of 0 is 0. So you put it all together. X raised to 3 plus 1 is x cubed plus 1. And then I believe this just cancels, right? So now they want you to find f prime of 2. So it's going to be 2 cubed plus 1, which is the square root of 2 cubed, which is 248, plus 1, and that gives you a square root of 9, which is 3. Okay, so let's move on to 11. Okay, so 11, we have the integral from -3 to k of x squared dx. And somehow we got to figure out what k is. So this is slightly different. So if you remember, or if you recall, that from the integral from a to a of f of x d of x is going to give you 0. So I think our k is equal to -3. Um, or you could do this. You can say, what's the integral of x squared? It is x cubed over 3 from -3 to k. So I just took the integral of x squared. Now I'm going to do the fundamental. And what happens is you apply the upper boundary. It's going to be k cubed over 3 minus bracket, and then it's going to be -3 cubed 3. And then you're going to set that to 0. And then you'll solve for k. So it's not too bad, right? So k cubed is going to be k cubed is k cubed over 3 minus -3 to the third is -27 over 3, which is -9. So it's a -9 equals 0. And we know that two negatives become a positive. So it's k3 over 3 plus 9 is 0. And solve for k by subtracting 9. So you get uh, k3 over 3 plus -9. And then go and solve for k by cross multiplying. So 1 times k3 is k3. And then 3 times -9 is -27. And if you solve for k, you got to get rid of the power 3 by raising everything to the 1/3. So that's k equals -27 raised to the 1/3. It's -3. Okay, so my k is -3. Okay, let's move on to, there's only two more problems left, so let's move on to two. Sorry. Okay, so number 12 says, we have the integrals from a to b of f of x c of x equals a plus 2b. Then the integral from a to b of f of x plus 5 of d of x equals what? So what we could do is break it to two parts. We said from integrals a to b of f of x d of x plus the integral a to 5 dx. So what's the integral of f of x d of x? That was given, and it's actually a plus 2b. And what's the integral of a to b of 5 dx? Well, they don't give us that, but we could figure out what's in integral 5, which is 5x. And then do the fundamental, so upper minus lower, right? So that's going to be 5b. It's 5a. So all you got to do is add them up. Yeah, you're not going to get like a constant. We're going to have some kind of letters. And that gives me, so that gives me, so it's a plus 2b is 5b minus 5a. So when you add them up, 5b plus 2b is 7b. 1a minus 4a is negative 4a. There you go. That's your final answer. Okay, let's move on to 15 then. Okay, so 13, we have to find the integral from 0 to 1 of square root of x times x plus 1 of d of x. So what would I do? I would not do u substitution. I might have to FOIL out the square root of x and then just take the integral of each term, right? But maybe I can rewrite square root of x. They're all in power, so this is an invisible one. As a power, right? So square root of x is the same thing as x to the 1/2. And then it's x plus 1 times dx. Okay, so if you recall, if you FOIL it out and you're multiplying powers at the same base, for example, x3 times x2, you add the power, so this is x5. So I'm just FOILing this out. So it's going to be from 0 to 1, and then x, and then 1. This is like invisible 1, this is 1/2. So what's when you add 1/2 plus 1, or this 1 is the same thing as 2, that is the inverse, right? So that's x to the 3/2. Okay. And then x to the 1/2 times 1 is x to the 1/2 of d of x. Now you may take the integral of each term. So what is the integral of x to the 3/2? It is 1 power plus 1. So okay, you say 1 is 2 over 2 over that new power. So what's 3/2 plus 2 over 2? It's 5/2 plus x, and then it's going to be old power plus 1 or 2 over 2 divided by that power. So that makes 2. Let's clean it up before we apply the fundamental. So this is going to be uh, x 3/2 plus 2 over 2 is 5/2 divided by 5 over 2 plus x, and then 1/2 plus 2 over 2 is 3/2 divided by 3 over 2. So right here you have a complex fraction. This becomes, I guess you can multiply both sides by 2. So this will become 2x to the 5/2 over, and 2 times 5/2, the 2's cancel each other, 5. Plus over here we have also a complex fraction. If we multiply this by 2, it's going to be 2x to the 3/2 over 3. And you can apply your fundamental from 0 to 1, right? So upper minus lower. And so it's going to be 2 to the 1 to the 5/2 plus 5 plus 2 to the 1 to the 3/2 or 3 minus bracket. This would be 0 plus 0. And do all that work, get 1615. Okay, so number 14, the last one. We got to take the integral. So we got to take the integral from -3 to +3 of absolute value of x plus 2 of d of x. So, um, how would I do this? I don't think there's like a special, like there's no, I don't think there's a technique that I know of. What I would do is like draw it and then go from there. So how does the graph of y equals absolute value of x plus 2 graph looks like? That looks like this, right? Where so this is -2, and then dot sign and the V shape, right? And then we're going from the boundaries -3, so we got to figure out what this y value is. And then our upper boundary is +3, so there's 3 right there. So what you could do is we got to find out this area. Let's call this area 1, and then this area. So what it is the shape? It is the shape of a triangle. So if you look at shape 1, it is a triangle. So what is the area of a triangle? It is 1/2 based side, right? So it's going to be 1/2. The base is what is it going to be? Wait, let's first figure out what is the y value when you plug in -3. So if you plug in -3, you get absolute value of -3 plus 2, which is the absolute value of -3 plus 2 is -1. Absolute value of -1 is 1. So I think that's our height, right? So my height is 1. And then what is my base? Oh, -1, right? -1. I'm going to use +1 because this area is going to have to be positive, can't be negative. So it's just going to be +1. So from -3 to -2, that's a distance of 1. So yeah, so that's going to be 1/2. Now, what about the area? This is right base. What is the area of triangle 2? So we're going from 3. So first, what I'm going to do is first figure out what the height is. So plug in 3 to your function. So it's value 3 plus 2, which is absolute value of 3 plus 2 is 5. The absolute value of 5 is 5. So it's going to be 1/2 base. What is my base? So we're going from -2 to 3. So it's a total of 1, 2, uh, 1, 2, 3, 4, 5. And then we said our height was also 5. So when you put it all together, we get 25/2. So the total area is 1/2 plus 25/2, which is 26/2, which is 13. Okay, so yeah, that is this is part 1 of the integration final exams for calculus 1. So there might be a part 2. So I'm going to stop here.